Welcome back to this lecture series on my new book, Artificial Intelligence, Neurodata, and Society, Law at the Edge of Cognition. This is Dr. Mark Leiser. This is a lecture series that I've been putting together to explain to people the basic principles of what my book is about, and hopefully be able to buy the book from Bloomsbury's website and learn more about these concepts and ideas. Chapter 3 moves neuro AI into one of the state's most coercive settings, criminal investigation. So the attraction is easy to understand. If you're a lawyer or the Crown or the prosecutor, EEG, functional MRI, and AI-assisted classifiers appear to offer access to recognition, memory, whether somebody's being deceptive, or emerging intention when testimony remains incomplete or unreliable. Yet my chapter draws a firm distinction between investigative utility and evidentiary authority. A signal may suggest a line of inquiry without proving guilt. A model may help prioritize attention without establishing what a person knew or intended. That distinction becomes difficult to maintain once cognitive scores enter police workflow. They influence who is being questioned, which leads receive resources, how investigators interpret ambiguity. So this lecture examines the scientific foundations, the architecture of adaptive investigative intelligence, and the deeper shift in legal truth that occurs when the state begins to treat the brain as a source of actionable suspicion. Technical sophistication cannot determine legal legitimacy. The progression on this slide is not simply a history of better evidence. It's a movement in where authority resides. Testimony is fallible, but it enters, especially in the UK and the US, adversarial processes. A witness can be questioned, context supplied, contradiction exposed. Physical traces and digital records require interpretation, yet investigators can usually identify a chain of custody and a proposition to test. Neurodata sits at a more abstract point. The raw signal means little until experimental protocol, pre-processing, and classification translate it into recognition, deception, or intent. As policing moves inward, contestability declines when the aura of objectivity grows. That combination creates normative risk. The individual may struggle to explain why a neural response appeared, whether stress altered it, or whether prior exposure counts for familiarity. The model's inference can therefore become more authoritative precisely as the subject's capacity to answer it becomes weaker. So my chapter calls for an epistemic restraint at this point of transition. Once that distinction is blurred, an investigatory aid can acquire the authority of evidence long before courts have examined its scientific or constitutional foundations. The scientific distinctions really are important because brain data is too blunt a legal category. EEG, for example, provides multi-second level temporal sensitivity, but weak spatial precision and substantial vulnerability to muscle movement, environmental noise, and stress. The P300 response indicates recognition or salience. It does not identify guilt. Functional MRI offers richer spatial localization through blood oxygen signals, but with delay and heavy dependence on statistical modeling. The famous dead salmon demonstration remains a useful warning about spurious activation when analytical corrections fail. Brain-computer interfaces promise more direct access to motor preparation and other pre-action signals, but remain context-dependent and difficult to generalize. The typology adds another layer. Passive data records baseline or spontaneous activity. Active data follows a controlled stimulus. Inferred data uses models to ascribe a cognitive state. Each step increases interpretive ambition. Legal safeguards must therefore track how far the system moves from measured signal to normative conclusion. The modality matters because active and inferred data enlist the subject and intensify the leap from physiological response to claims about knowledge, memory, or intention. Scenario 5 deliberately exaggerates none of the underlying temptations. The suspect sees crime-related images while the system reports recognition, deception, and intent with quantified confidence. The interrogator says, "It is science," and that phrase captures the institutional danger. Recognition may reflect prior exposure rather than participation. Stress generated by custody may resemble deception. A readiness signal may indicate motor preparation without establishing a plan to commit an offense. The visual score compresses these ambiguities into a single investigative narrative. Bias in the training data compounds the problem because a model calibrated on one population may interpret another population's physiological response through the wrong baseline. The scenario marks the point where assistants become epistemic authority. Even if the output never reaches court, it can shape questioning, charging, prosecutorial focus. Suspicion begins to look discovered rather than constructed, and the model's opacity makes that construction difficult to challenge. The scenario shows probability hardening into an institutional narrative of guilt. The multi-layered mesh is the chapter's most constructive account of possible use. Neurodata does not function alone. AI can combine a P300 response with speech hesitation, gaze, device metadata, location, and other contextual signals. It can surface non-obvious connections, identify zones of evidentiary potential, and allocate investigative attention. The chapter describes strategic selectivity and iterative tactility, the capacity to revisit a signal as new context emerges, to demote an earlier false positive, and to treat the output as a provisional rather than conclusive. This is an attractive vision, but it depends on strict institutional discipline. The model should generate prompts for independent investigation, not hidden verdicts. It should preserve uncertainty, require corroboration, and expose the chain through which each input changes a score. Otherwise, interoperability magnifies rather than cures error. A weak neural signal gains authority simply because multiple systems repeat and reinforce it. The mesh can become a machinery for self-validating suspicion. This is investigative power at the level of attention. The system decides which inconsistency deserves pressure and which alternative account will receive less institutional energy. The chapter now moves from forensic technique to legal epistemology. Criminal procedure does not promise metaphysical certainty. It produces legitimate findings through structured contest. Claims are articulated, reasons exchanged, burdens allocated, and errors treated as possible. Nicholson's account is central here. The value of the adversarial process lies not simply in its efficiency at discovering historical truth, but in constraining state power and making judgment publicly defensible. Neuro-AI introduces a different coherence. The model's output gains authority because its patterns fit a high-dimensional feature space and because validation occurred elsewhere. A confidence score can look cleaner than a contested narrative, but it does not supply reasons in the legal sense. The danger is authority drift. Numbers begin to displace explanation, and the jury risks becoming a dashboard. If the system's internal consistency substitutes for public contestability, the institution changes what it means by truth without openly acknowledging the change. What changes is the grammar of truth itself, because model coherence begins to substitute for the public, discursive coherence produced through legal procedure. Follow the pipeline on this slide from left to right. A stimulus produces an event-related potential. Pre-processing isolates those features. A classifier maps those features onto a label. Investigators then translate the label onto an evidentiary claim. At every stage, assumptions enter. Which stimulus counts as relevant? How noise is removed? What does the training label mean? Which confidence threshold triggers escalation, and how the final claim is worded? A P300 response may begin as pattern consistent with recognition and end as the suspect knew. The technical pipeline becomes constitutional because each translation affects silence, self-incrimination, presumption of innocence, and the defense's capacity to contest the state's account. The chapter's warning is not that probabilistic tools have no investigative value. It is that uncertainty must not disappear as the output moves through institutional language. A system designed to focus attention cannot be allowed to manufacture the very fact that it was supposed to investigate. Each arrow therefore represents a normative translation. not merely a technical stage, and every translation requires an accountable justification rather than a confidence score. So Chapter 3 leaves us with a principled line. Neurodata may sometimes guide lawful investigative attention, especially where the output remains provisional, independently corroborated, and open to revision. But it cannot carry the authority of proof merely because a classifier makes cognition look measurable. The closer the state moves from observable act to inferred mental antecedent, the stronger demands of consent, necessity, proportionality, and contestability must become. Otherwise, policing converts probabilistic correlation into preemptive judgment and treats the brain as a witness that cannot speak for itself. The inward arc of surveillance then reshapes the subject of criminal law, not a person judged for acts, but a pattern managed for predicted meaning. Don't forget to check out the next video in this series, where we turn to Chapter 4, The Mind on Trial, and examine what happens when neuro-AI inferences are offered as evidence. The next chapter tests that line when an investigative signal enters adjudication.